and welcome to your video on position time graphs. Our guiding question for this video is going to be, what can position time graphs tell us about the motion of an object? And in this case, we're going to use an example of a man moving back and forth, going from the starting point to a house and going back. First up, we need to make sure we know what the parts of a position time graph are. So we've got our standard X and Y axis, and on our X axis is always going to be time. And usually we're going to have the units of seconds. And we're going to show that by putting in parentheses our units. This can be hours, this can be minutes, but in most cases it's going to be seconds. On our y-axis, we're going to have our position. And in this case, it's going to be in meters. But this could also be centimeters or kilometers or miles. But in most cases in our class, we're going to have position in meters and time in seconds. There will be some graphs that you come across that instead of using the word position, they use the word distance. Sometimes they can be used interchangeably. For most of the cases in our class, position in meters and distance in meters, we can kind of use the same way. The interpretation will be, for the most part, the same either way. Okay, so here's our moving man, and we have a moving man up here, and we're going to watch him move and see what graphs are made down here. We've got our position on our y-axis, and we've got our time on our x-axis here. So let's see what happens when we just press play and he doesn't move. Okay. We get a basic straight line going across and he's not moving. And we could change that position. We can have him teleport to 6. Oh, quick little teleportation, going to 6 meters, and he's just going to hang out here. Well, this is all kind of boring. Let's get this guy moving. Okay, so what we have here is our moving man, and we have a graph here, and what I notice is a positive slope. So let's see what motion would cause a positive slope. So we have this little guy here. Let's see what happens. To make a positive slope, he's going to start at 0 and he's going to move away from 0 and go towards the house. Big key word is he's moving away. He's getting further and further away from the starting position as time goes on. We're going to call that constant velocity. Constant meaning his speed or his velocity is not changing. Okay, his position's changing, so his position is not constant, but his velocity is constant, and it's changing. Oh goodness, his position's changing, but he's at a constant velocity. And to make that action, let's watch it again, he's going away from 0. He's going away from his starting position and basically going to his destination. Okay, so now let's see what happens when we get a negative slope. So what I notice here is we have a negative slope, and let's find out what that means. It looks like in this situation, this time he's going to start at the house and have some motion that's going to cause it to go back to 0. So let's see what happens. Okay, it looks like he is moving towards 0, or he's going back to the beginning. Okay, so to make a negative slope, he's going to go towards the beginning. All right, so now let's see what happens when we combine a couple different slopes. So what I notice on this graph now is I see two positive slopes, but they're two different ones. I see one that's kind of flat, and I see one that's kind of steep. Let's see what motion causes the slopes to change. So again, positive, so he's going to go away from the start, and then when we change it, oh, he's going to go a lot faster. So to cause this motion, he went slow, going away, and then he went fast. Okay, so we can make this even a little bit more interesting. Okay, so now we've got a really interesting graph. I notice a line segment of a positive slope, kind of flat. Another graph, I notice a more steeper slope. I also notice a flat no slope and then a steep negative slope. So what we can do is we can kind of make little stories out of these graphs. So our first story could be a story about him starting at the soccer field and needing to go home, talk to his mom, and then maybe going back to the soccer field. So let's see how this story might unfold, the story that we can tell from this graph. So, gonna go home, remembered that he needed to go home and check in with his mom. And so he's walking home. Suddenly he looks at the time and goes, oh, I'm gonna be late, I better run home. So he goes faster and goes home, and then he's at home. He's gonna talk to his mom, maybe grab a snack, maybe get some water because it's hot out, and hang out, talking to mom. Mom's like, you know what, get back out of there, go back to the soccer field. And he's so excited that he gets to run back to the soccer field so that he can continue playing soccer with his friends. And he runs because he's excited and has a fast velocity. So every different segment can tell a different story of what went on. So let's see how we can do this in a different way in maybe a homework assignment that you might find. Okay, so what you might get in a test or a homework assignment is different segments of a graph that you need to say what's happening. And we'll often put letters at the different changes. So we'll have A, B line, and we'll have to describe what's happening here. And then you'll have between B and C and have to describe what happens here. C and D, what happens here, and between D and E. So let's kind of quiz ourselves here. Let's look at A to B. Think to yourself, what is going on between A and B? Okay. So between A and B, the object is stopped, and it's stopped at 20 meters. Let's move on to the next segment, between B and C. What is going on between B and C? Between B and C, we have a constant velocity going away from start. So we could say two different things. The positive slope is going to tell us that it's constant velocity and we're going away from start. What's happening between C and D? Between C and D, again, we are stopped. The object is stopped, but this time it's stopped at 60 meters. And then let's finally think about what's going on between D and E. Between D and E, we have a constant velocity, but this time going towards start. So notice both cases we have a constant velocity. If we have a straight line slope, we're going to have a constant velocity. Positive tells us we're going away. Negative says we're going towards. Okay. This is the end of our video on position time graphs.